What we did yesterday?
What?
What we did yesterday?
Yesterday leave.
Oh, yesterday leave. Okay. Before yesterday.
We start a rapid roster. Yes, basics.
Have you tried? That
No,
Repetier host you tried?
you tells 2 or 3 commands only.
So you tried that or not?
No, you don't do anything. You show only this one, that like that only.
Okay.
Don't do
You
nothing.
create one STL file and import to the Repetier host or not?
What do you say?
I'm saying, did you create any part on any 3D modeling software and convert it into STL and open into Repetier host?
Oh no.
Why?
Already I have a model for SolidWorks base, but I can't do it.
Okay, no problem. You save that files into STL format and try to open into Repetier host. Okay. Now I'm opening it again. Now we did that particular part which we created in the SolidWorks. Now let's open that and we reduce the scale of that part. Okay, that because this is a big part. Now it is not on the bed 2 part. It is not available. So what we do, we are changing that part with the scale. That part name is, I think, part 1. I'm creating a small part today, the same type. Okay, because we need to place into the bed size. Make sure the part should be less than that. If we are creating a multiple parts are there, so we have to create a small one. Okay. Now I'm creating, suppose the width we are taking here 30 mm. Same type of part we are creating today also. Okay. Okay, now we have to print this file. So we have to save this file into STL first, so that we can open into STL part 1. We are replacing the file. Now, going to open here in our Repetier host. How we open? Go to file, and you can load from here. You can use Ctrl+O. Okay. Otherwise, what we can do? Go to load directly here. STL and table will be there, which are already we are importing into. Okay. Now we are going to load a new part here. Part name is part 1. Open. Now see, it is loaded. Is it visible to you? It's loaded.
Which one?
The screen is visible to you now. The part is loaded.
Yeah. Yeah.
Okay. Now see, it is not perfectly loaded now. If it is look like this, so we need to place here extra support material, both sides. But what we need to do, we need to reverse it. Here we have multiple options. So like we are already learned about this part. Add object, you can open a new project here also, new part also. If you want to copy this component, you can copy it. But right now we have to rotate it by 180 degree by y-axis. So here we have a command rotate, and you can give here 190 degree. Now it is perfectly added. Okay.
Where is your mouse?
Sorry.
I got stuck in your video.
Stuck.
Yeah.
The part will be flat right now. It is visible that not
Visible, but you can mouse clicking stuck.
I think it is okay, not a stuck. I am rotating the part. Is it visible?
That rotating option I can't see, but it can't stuck.
Okay, rotate option is here. See this one.
Repeat again. Okay.
And then X, Y, and Z directions will be visible. These are the axes. Okay, so we need to find out which axis we want to rotate. So here, coordinate system will be there. Yes, you can find out about which axis you want to rotate. So we need to rotate by Y axis. That's why I'm taking here 180 degree into Y axis. Okay, so it is now added perfectly. Now it is at center by default, but we need to place some more objects here. So we are going to copy it. So here we have command copy. Click on it, copy. They're asking for number of copies you want to copy here. So let's say suppose I need 4 objects, and click on the copy. I say it is taken auto position after adding object. Just click on the copy, automatically adjusted the shape. See, 4 more we are placed here. Okay. Now we have separate part and separate settings for the part. Can you see it?
If
We
more
have part
space,
1, part 1.
if
Sorry?
more space required means how I copy more numbers.
How to copy more numbers? See, for more numbers, we can again go to copy and increase the number.
No, we have with enough size for that 3D printer plate. For that object also same with what can I do?
You need to reduce your scale of the body.
Size will be reduced or not?
That is reducible. Here also we can reduce.
Physical object is size reduce or not?
Yes, you can. See, first is you can reduce the scale of the part into your 3D modeling software. Okay?
Okay.
Or if you are created but you want to scale it here, so here also we can scale. See, just suppose we have this part, I want to reduce the scale, its size. So here we have next command, this one. Before this rotate, here we have scale other option. Click on it and see in which direction you want to scale. I said scale to same them, means I need to shape required same. Okay, but size is low, so we can go with 0.5. See, it is reducible. Okay.
No, I got printer machine also same dimension.
Sorry.
Printer machine also same physical object that size.
I'm not getting you. What printer?
After we printer machine to get a result for physical object, okay, that object also we can reduce this dimension.
We reduce dimension. This is the reducible. See, we reduce by 1.5. Sorry, half.
But I want if suppose I some customer asked me some dimension miss, but I required more copies, so I can reduce the scale and then create the new object for more copies. It acceptable or not?
See, if customer required this size, so you have to give this size. If this size is basically that size scale, okay, so you need to give this one as a single part. Every time when you have to create 5 parts, you have to give 5 times print. If you want this scale, if you want the prototype of that, so you can reduce the size and then print. If this is based on customer requirement. If customer required the base size of this product is 200 by 200, so you can print only one part.
Okay.
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 But we have the printer size only 230 by 230. We have to print the part inside it.
Okay.
If you want more numbers of parts are there, you have to separate print. Clear?
Yeah, clear.
Okay. Now see, these are the command number of copies. Now here we have some more options in the particular part. See which part you see. I am changing this part by reducing the scale by 0.5. If you want to rotate this part, so you can select from here which part you want to rotate. You can click to rotate, and then you can see you can add. But now you want this size part. You want to print it like this. You can print like this also. Okay, but in this case you need supporting material also here.
We placed which size means that object will created.
Yes.
Is extra support means we put it or automatically it created.
We need to give settings, na printer settings. There we apply the support material. If our part in the air, some portion will be in the air directly, so we need to give the support material there. Okay.
If support material for any disturbance for like gum or stitching to that.
No, we have to see when we are giving support material to a part, it's being created in a small layer, and its thickness is too small. And we can, when we are removing this part, we have to remove that material also. I show you then into the video. I show you that. See, any type of part you can create. Now this is this part. See, the wire is insert to the extruder. Now see, it's working. Support material is we are using into PVA here. See that all outer side material will be the supporting part. The outer side material will be the supporting part. This is in the pillar type. See, the supporting material will be removed.
Is melted.
And then liquid, it will melt. PVA is dissolved in that material.
Okay. If we always use here that PVA.
In general software, we are using PVA as a support material.
It's costly or
sorry?
costly or no?
No, it is not costly. And I show you that if you want to remove it manually, you can also remove it manually.
It did not tell me about the PVA properties, anything.
I told you about the PVA.
You told only PVA full form. What can that advantage and that properties we can say, I think.
Okay, in this FDM technology, we are using PVA as a supporting material. I told you that now. Now, what do you want? PVA properties.
Yeah, because PVA is important for excess material. I wish to that properties what can do, how much cost is expensive or not. It's which substance is more add up.
Okay, so I'll mm, tell you that properties also. Okay, that is not the issue. It is not removing that material manually. Na? Otherwise, you can remove the material manually also. By the cutter, you can remove that. See, it will create a manually. See, the supporting file is there also. See, on the bed.
Yeah, okay.
This is supporting PVA material. It is manually cut it from the PVA and now finish it. We have to give the finishing properly. Okay. Otherwise, we can use a soluble material in which the PVA is going to be dissolved. So that our now material will be
We can buy a 3D printer machine. We can able to possible to create a physical object.
yes.
We
This is the
can
physics.
use.
You can use that parts also.
If we want only filaments and that machine.
You want only filament. That should be PLA or ABS.
Okay, okay, okay.
Okay. Now we are
Is
going to
if 3D printing, how much cost?
3D printer
Yeah,
or printing only.
printing.
If you
I
are
want if I want physical object means that machine how much?
okay. Now see, first you have to calculate its volume in CC. Okay.
Okay.
You have to go to our modeling software and you can go to the evaluate and you can measure its volume. Sorry, mass properties. You can see its volume is it is in cubic millimeter right now. We have to give here into centimeter. So what we do, change this unit, CGS, and then mass property into, it is 9.20 cubic centimeter right now, 9.2 cc. And general cost of the part is 60 rupees per cc.
60.
60, normal
Oh,
cost. So if you are going to print that file from the printer, near about cost is 600 for this file.
we that filament size
Filament size is 1.75 mm in diameter.
1 cubic. Yeah.
Sorry,
Why how much required for that 1 cubic centimeter?
that will be provided by the 3D printer. When we are working on it, when we are giving the command on it, so we can see how much length we required and what volume we required to create it. So that is available into the software also. Okay, I will tell you that when we are going to print it now.
Yeah, yeah.
And the filament prices you can see here.
Because I can't see any printer shop, 3D printing shop in my area. That only I ask.
Sorry,
I can't see in my life 3D printing shop. How to it created it. Now only I know that you tell me.
I'm not getting you. What you want to try to say?
3D printing shop I can't see in my life.
3D printing shape.
Shop. If I how to create it 3D printing machines and where is the location more required?
You want to buy a 3D printer?
No,
Yes. You want shop, na? Which kind of shop? Where 3D parts are going to print?
yeah.
Uh, I'm not sure into Chennai, but here in NCR we have many companies which are going to print the part using 3D printers.
What the
Okay.
purpose of the 3D printing?
What is the purpose? I
Yeah,
told you.
if company is for a prototype, yeah.
No. Before they are using as a prototype, but nowadays we can use a part directly.
But filament, it's more strong or use
Sorry,
if filament
filament.
are more strong, but because of we can usable for our lifestyle means it give more
Yes.
strong
Now
filament.
many types of material are there. I'm telling you about a small printer which cost about 30,000 to 1 lakh. That should be created into PLA. Okay, this
Okay,
material visible on the screen. But
okay.
in case you are going to use high quality parts, so we have to go with the powdered material.
It's more
Okay,
costly.
it's more costly.
Okay.
Now, right now, if you want to use shoes, so the shoe soles also created through 3D printer. The flexible portion, the flexible
Okay.
materials are also there. I told you about all kind of material and all kind of technology. Yes, so we can use any technology and using which kind of part basically we require. We have to use that technology, that material. If you want strong material, I told you stainless steel material also used, titanium is also used, nickel, cobalt is also used. Yes, when we want the flexibility, so we go with ABS, PLA, and all. Okay,
Yeah,
these are the
okay.
hard material. Hard material we can use in daily life also. You can see more videos into the YouTube related to 3D printer. You can see there are multiple types of parts are there which are used in daily life also. Even in the medical industry, the prototypes of skeleton for surgery for training purpose, they are using the 3D printing parts.
So we can normal people can also create to open a new print 3D print shop is possible, huh?
Yes, possible. Near about you need to take a printer which costs you 5 to 10 lakh rupees, and you can start your business also.
And 10 to
5 to 10 lakh rupees printer you need to
investment,
buy.
huh?
Investment. If you want to create a new business for 3D
Okay.
printing, you can try. No, this is not a
Oh,
big. Any
okay.
kind of part you can print through that printer. You need to
Yeah.
learn 3D printing settings first. How to use the 3D printer. Okay,
That
some
machine
printers
maintenance occurs unda.
maintenance is only about the nozzle and the PCB. The electronic fault will be there. Okay, so that is the
Okay.
maintenance only there. Or about the nozzles. Generally, what nozzle is going to be jammed with this material. So you have to use properly. Otherwise, nozzles are jammed. We need to replace. We need to maintain that particular. Okay.
Okay.
If this is a powder-based portion, so there is no need to nozzles. They are already through laser, through electron beam. Okay, so we can create easily. If you are going with this kind of material, that is passed through nozzle. So nozzle will be jammed through these materials. It is in powder, there is no need to maintain anything. We need to maintain only the electrical portion, electronic items. Okay.
Yeah.
Now, next one we have separate changes into separate parts also. Okay. Now we have settings also for the parts. This is about add object. If you want to add new object, this is about the copy object. You can more copies printed together. You can go with copy. Now here we have array also. Sorry, this is a auto position. See, it is automatically set auto position. If your part is not here, suppose this part is going to be moved to this side. Suppose you want to print it here, you can move this part. Take a move command and you can move it. Okay. You want to move this part, select this part, and you can want to move it. So go to move command, you can move to this side. So where you want to print it, you can. Now after that you said, no sir, I don't want to print it here. I want to all put it into the center. What we can do, auto position. Write to your copy command. See, again they are on same center position. Okay, that is auto position command. Clear?
Yeah, clear.
Next we have a center object. You want to place one object at the center.
If I placed separately means it create one by one or continuously create that place.
You can use for particular part also. You can use all parts at the same time also. Auto position is for all the parts.
But only one filament is available. One area only created. How to create a more area? If we have 5 copies means one by one it created or same time it can be created.
Same time. See, first layer for all, second layer for all, one at a time, all are printing together. It is not
No
like
extra, no filament wastage is possible.
that. No filament basis. It is not like that. First we are going to print this file, first file, then it is completed, then it starts second file. No. It is started from 0 to end at the same time. All 5 parts are ready together. Okay?
Okay.
Because it's created layer by layer. How many parts are there? The printer doesn't know they are a separate parts. For the printer, this is a one part and it is in the gap. Okay. Now, if you want to print, let's suppose I'm moving all the objects at the corner. Now you want one part at center. Which part? Suppose it's small one part you want at print at center. So what you can do here, we have one command, center object. Click on it, it should be at center. See? Okay. So here we have add object. We learn about this copy object. We learn about this auto position. We learn about this center object. We already learned about the scale. If you want to stretch it, suppose this part is going to be stretched. This part you want to stretch into X direction. Let's see what direction is here. Into Y direction. See, you want to stretch into Y direction only. So you can go to the scale command, and here we have to stretch double into this direction. See, it is taken by default all. I need to stretch only. This is a scale to maximum option. One part you can scale till this size, this part. This is the maximum size of the part we can print. Okay. Reset it. So we can place it like this, the maximum, and can scale it. Now next rotate we already did. Then we have cross section. If you want to see the part cross section, inside it is a complete solid inside, or it is we have a different kind of shape. We can see through cross section. Here we have command cross section. You can use C command for it. C, take it. Now see, it is hollow from inside. Is it clear? Visible? You can see its position also. Where you want to see this part, it is only created surfaces.
What is this?
Sorry?
Why this use?
This is cross section, inside portion, inside shapes we want to see. So we can go with the cross section of the part.
Okay.
It is only visibility. See, it is hollow from inside. You can see. Only outer material will be created.
If we created only solid material, how to it allow?
If you want to create a solid material, we have to go for the printer settings first. So I tell you about the command first, then we go for the printer settings also, where we can see inside shape.
What we created in SolidWorks is a solid part, correct?
This is a solid part. When it is converted into STL, it is converted into surface.
If converted to STL means it's automatically changed into hello.
Yes, it is a surface part now. Okay, it will create like inside hollow, but if you want to give some extra material inside for the strength of the part, so we can give that also. Here we want, suppose grid, inside you want grid shape, if inside you want a polygon shape, so many multiple shapes are also there. I can show you that also. Okay, when we are giving printer settings, then we can see that portion also. Okay, this is the position of a, this is the first layer. Then layer by layer, it will be printed like this. Okay. And now it is complete part. And if you want to see it from angle, so inclination and azimuth is also there. You can see the section from this side. Suppose I have a section, and now I want to see at angle. So you can azimuth angle or inclination. You can see. It is see. This is at angle. Okay, or you can see the other side. This side angle is not available. This side angle will be available. You can see like this. I show you. Okay, this is at angle. See, this part shows at angle. If you want to see the layers at angle, we can use inclination, azimuth. As per requirement, we can see. Okay, this is about the craft. And last, if you want to take, no, it is not like this. I want to place it as a mirror. So one thing we can do, we can rotate it. If you want mirror, we can rotate it by this z-axis 180 degree. We get the mirror object. But if you want direct mirror option, so here we have the last option is mirror. This is mirror object. You can use M command. Let's say it shows because this product is the same type, na? So mirror is not visible properly in it. From everywhere it is. I can choose this one. Now click on mirror. The same part is there, so mirror is not visible properly here because when it is rotated, it shows same. Yes. Clear? Now I
Yeah.
want to remove the part. Some parts I am going to remove, and this part should be at at center we require. Okay. Now this is the mirror is not visible in it. So what we can do, we are importing some other part first. Suppose I'm deleting this one. I'm opening the other part.
Your screen struck.
Okay. I think a network issue is there. This is the part placement basically. Now visible?
No.
I delete the object. It's visible. Delete the object. What screen is
No.
visible to you?
No, it's stuck. His video is stuck.
Now visible.
Yeah.
The all parts are deleted. Okay. Now I'm taking a like part which is different from all sides, so that if we are going to mirror it, it will be visible. So we can open the table file here. Okay. It is also the same type file. Now try to mirror it. Now see it is changes. Na? You can measure the changes. This is mirror. Okay.
What difference mirror?
See, first is
What is
this side is portion. This side is you want this portion should be this side. You can go to mirror it. It is mirror about the center.
okay? If
Okay.
another axis we want to access means
You can. This is the basically purpose for placing the part. How we want to print it. How we want to place it. So this all commands is basically used for placement. Okay.
just how to place the object. Only we know it's right or corner or this side or scaling, rotation, cross sections.
This is all about the part placement, which
Okay,
is going to
okay.
be okay. The command
First
name also
point,
here, object
first
placement.
point we in printer machine we put the part position object.
Yes.
Okay.
Now we can see about
Hello.
Yes. Hello, are you there?
Yeah.
Okay. Now, next what we have here.
we are going to part settings first. See what settings are available here. Select your part and then you have to go to settings here. You can delete the part from here also. The cursor is visible to you.
Which one?
You can see in the right side it is written tablet.
Your mouse not moving. Yeah. Something issue.
Today my broadband connection is not getting properly. That's why this issue we are facing. Now visible?
Yeah, visible.
Now see, this is the tablet part which we are taking here. Then here you can see one object I. It is for hide and show. Okay.
Yeah, okay.
And here in the last we have delete button. We can delete our parts whenever you want. Or here we have some settings of the part. Now
If
click on
deleted
it.
mean we can restore or not?
No, you need to load it again.
Once deleted, we cannot use.
Yes.
If a
Now
control
we are
Z means, if control Z means is visible or not?
no. You have to load it again. See, this is deleted now. So control Z is not working here. You have
Because
to go to again load and load
because
your part.
with design software we can use control Z means it automatically restored. That only I asked.
No. Here the control Z is not working if you are deleting.
Okay.
Okay. Now
Okay.
see here we have some options to part analysis. Now we are going to settings of the part. Click on this button. And here we have settings of the filament. Okay. You can see the part name is 1. Here we are using extruder 1. If you have printer, you can use. I have only one extruder right now, so we are taking 1. Assign object is group number 7. It shows you group number 7. See, because we deleted 6 objects before. Okay, that's why it shows group number 7. That is 7th number of group. Okay, if you want to extract this file, you can extract from the group. You want to split this object, you can split. You want to fix this, you can fix. But before this, we are not using this. Before we are going to analysis it. See what we required for this. So here we have button analysis. Write to your settings. Click on this analysis tab, and you can see here.
Stuck.
Sorry.
Your mouse stuck in Windows. Yeah, now okay.
See, this is the analysis part. How many parts are there? 1. How many faces are there? 1976. How many points are there? 988. What is the volume? See, it is in CC 83.6051. How many edges are there? How many surfaces are there? Okay. What are the dimensions of the part?
What is that shell, face, points, edges?
Shell means it is a hollow from inside, na?
Okay.
You learn about the shell command. Here we have only using one shell.
Face.
Okay. The time. Sorry.
Faces, points means which one may it mention?
Faces and points which are available onto your part. How many faces? See, every face is a separate face now. When it is converted into STL, na, so I show you that it is converted into triangle.
Yeah.
Every triangle having separate face now.
Okay.
Every triangle having three edges separate now. So that's why here 2964 edges.
Based on your volume of object, it automatically calculate the faces, points, edges.
When you are converted into STL, na, that file will be analysis, and then edges and faces are counted.
Automatically,
edges, faces you can see when you are converted the file into SolidWorks also. The screen pop-up window will be there, na? How many faces are created. When you are converted into STL, you can see there also. Okay.
Okay.
Now, after this, you need to analysis the manifold, normals, intersecting tangles are there or not, highly connected edges, which one, how many loops will be created. We get to analyze first. Click on the analyze and see 7 triangles are intersecting each other. It shows no loop edges are there, highly connected edges, no. Okay, so we can analysis.
Manifold, what is manifold as option or normals oriented?
It is normally oriented. This part is from the flat shape. It is placed, na. This shows oriented, normal. Okay, and the manifolds are here. We have multiple folds are in this file. This is multiple folds basically. The bends are there, na.
Yeah.
If in your part there are multiple bends are there, it shows manifold. Yes. Otherwise, shows no. Where straight part is there. So, okay.
Intersecting the triangles means which one it mentioned?
Whenever in this file, when it will convert it into HTL, na.
Yeah.
Somewhere here we have conflicts. See here we have small faces, na. This one. So maybe that the triangles are being created here that are intersecting each other. Okay, that is about the part. Now, if you're taking our previous part, suppose I'm deleting this one. I'm going to load our file which we are created. Okay, now we are going to rotate it. Okay, now go to settings of it. Now go to analyze. See, this file is 9.1979. How many faces, edges, points are there? Analyze it. See, here we didn't have any triangle intersecting. It is based on the part what we are created. So it shows all the things about the part. Okay. Clear?
If intersecting triangles highly connected means is there any problem or create an object?
That is a problem.
Why that problem?
Your file.
We cannot able to create it.
Triangle means when it is going to be print. So by it is basically converted into triangles, na file. If the triangles are intersecting each other, that means the nozzle didn't know on which line we have to go. Okay, so sometimes some portion is not properly created when the intersecting triangles are there. So in the part we have to remove it.
If possible to create or not in.
We have to remove the triangles. If generally when we are created the part, na, that intersecting triangles are not there. When we are converting our STL file, na, we have to create a smoothen file. Okay.
Okay.
Now, this is about the part setting. After that, we are going for the printer setting. See, we have 2 types of printing settings are there. Some of the software printing settings, some of the printer printing settings. Okay.
Yeah.
So here we have in the top we have printer setting. If you are clicking on it, you can see the printer is connected or not. That is the connection portion. The printer is connected or not. If we are going to print it, so we have to connect it by using port, that USB. Okay. The bound rate should be there. Transfer protocol is auto detected. Low to high, DTRs and RTS. These are the connection settings. Okay, it is by default taken. Which type of connector you want to use here, series or parallel? a virtual printer, TCP connections. These are about other connection types. Generally, we are using series connector. Okay. So this is the connection setting. Here we have this printer setting. So in how much time it will take, so that depends on the travel speed. Okay.
Yeah,
so
yeah. Speed rate, speed.
Manual extrusion speed. Okay. This mm per minute per second. So there are different speeds are there. We can change it manually.
If
But
any standard parameters is available for
these
printer,
are the which is the standard parameters are given into the printer. They are purchasing it na. In the manual, the parameters are there.
user book available.
Yes. With the printer manual is there, in which the standard parameters are available. Okay.
Yeah, okay.
This is this software printer parameter. Generally, it will take this one. If you have the different speed, different types, you can change it here. Otherwise, we can do the same settings into the printer also. The printer itself also the same settings are available. We can input the files there also. That is touch screen printer. You can use there also. Okay.
Yeah, okay.
This is about the printer. What is the travel speed and all. What is the origin of it? So we are taking the origin is 000, same. Okay. And that all text should be there. The printer has SD card or not. Heat bed after job. We have to disable. Yes, the job is completed. It's going to be disable the heat means cooling period is on. Disable the extruder after the complete of the job. Okay, or killing the job means you have to cancel the job. So this will be clicked. So that printer is automatically cooling down. Okay. So that text should be there. Then about the extruder. First, you know about the extruder. What is extruder? Extruder is the type of bolt itself in which we have a hole. From that hole, the filament should be passed. So that extruder, basically we had to give the heat. So that in the extruder, the material should be melt. I'll show you the extruder shape first for our printer. Extruder. Into the image. See here. This is the complete set of the extruder. Okay. You can see here this one. Here we have one part, the hole is there. See inside. The filament passes through this side, and other side will be, nozzle will be there. You can see here we have the nozzle other side. I show you it in this. See, this is the extruder hole. The filament passes through this side and passes through this nozzle after melting in between it. Okay. This is the extruder printer. Now you can see filament also there. See, the filament just passes through this side and it is going to be melted inside it, and then it is passes through the nozzle. Okay. This is the extruder printer. This complete set is known as extruder. When the material is in between, suppose you are printing it and in between cooling down is there, so that material will be converted into solid again. between from this to this. So what we have to do, like we are going to preheat our extruder first because we have inside the material easily. That's why we are going to preheat it first. Similarly, directly don't close our 3D printer. First, we have to give this extruder the cooling period, so that what will happen, the material inside it is going outside from the nozzle, and this material is here stuck. Okay, so that this portion will be clean. Otherwise, extruder pins are also available to clean the extruder, clean the nozzle. Now I'll show you the nozzle first. 3D printing nozzle. So that you can better understand about the printer. See, this is the nozzle. So here we have a different shapes. Sorry, shape is same, different sizes are there. You can see 0.2 mm, 0.3, 0.4, 0.5, 0.6, 0.8 mm nozzles are there. You can see the dia of the nozzle is bigger from 0.2 to 0.8. Generally, we are using in our printer it is 0.4 mm. This one.
We can use same extruder for different nozzle.
Sorry.
If we can use same extruder with the different nozzle, possible?
Yes. See, only the bottom dia will be different. Otherwise, size will be same.
What is the purpose of the different dice nozzle?
That is basically how thinner layer you want to create. Okay, and if you want to create your part earlier, so we have to use maximum dia of the nozzle. So that part will be created earlier than the smaller size nozzle. So material is in larger amount, material will be extracted from the nozzle now, if the size is bigger. So thicker layer will be there. Okay, amount of the material is bigger, so that our part will be ready earlier.
Based on the size of the object.
Sorry?
Based on size of the object.
Yes.
If small ring means that we can use only a small nozzle.
No, that is not the. See, what strength you required also. If you are using a small dia nozzle, that means the thinner layer will be created, so that the strength is more to the part. Okay, maximum numbers of layer are increasing. Okay.
Yeah.
So that the part is more strengthened.
Single layer, how much thickness you know?
Sorry?
Single layer. If creating a single layer means
that is also we can decide when we are going to printer setting na, we can decide how much thicker layer we require. So that is depend on the nozzle. We require that much of amount of material in the same time. So that use how much which type of nozzle we required also. So we can decide when we are given the printer settings. Okay, now we are going to printer settings. You can see here in the printer setting. This is about the extruder. In this number of extruder, we have one. How many fans are there? We have one. Fan we are using when the melting material is extracted from the nozzle. Applied on.
Okay, that's why we are using fan there.
Yeah, you're stuck in your video. Hello.
Hello.
Yeah, our video stucking.
Hello.
Hello.
Yes.
Your video stucking. I can't see.
I'm using the same printer settings.
Yeah, printer setting.
In the extruder we are so number
Yeah.
of extruder, how many extruder you have? You are using single extruder, dual extruder, or triple extruder. So we have to give the settings in the settings. How many fans we are using here? Fan we are using for the cooling of the material on the bed. It is placed on the extruder itself. After extracting the nozzle, the fan is going to cool down the material so that that layer will be in solid. Okay.
Yeah.
And then the extruder temperature is taken 280. I told you about the ABS and PLA material extruder temperature. That will be 220. So we can type here 220. Bed temperature will be required in our case is 60. So we can provide a 60. What is the maximum volume per second, which is by the nozzle we require? So we can type the value here, how much we require. Okay. If you have one nozzle for all color, or you have mixing extruder, so you can use that also. You can tick on it. Otherwise, we are using for single color. So extruder 1 is there. If you have extruder 2, so 2 extruder settings are there. If we have 1, so we can use 1 extruder and 1 settings are there. You have to give some name to the extruder and what nozzle dia you are using. That is 0.4. See, by default we are using 0.4 mm dia of the nozzle. Now, if you are using which color, so you can use color also here. White color, blue color, which material you have available. You can filament color, you can provide it here.
Filament color based on that.
Sorry. See, here you can give any color, but the filament color, you have the filament color, na? It will create in the same color only.
Oh, okay.
Doesn't
If filament
it is,
color is black color means it only create black color.
yes. You have to choose that color here. Then we have offset value. What is the offset? The nozzle and extrude. The nozzle tip is how much gap with the bed. That is X and Y offset. So basically we have to take it at the origin. X is 0, Y is 0 means our nozzle is placed at the center of the bed. Okay.
Yeah.
If you want to place it at the corner, you have to give the value here. Clear?
Yeah.
So that is about the extruder. Then we have printer shape. This is your printer bed size. You have 230 by 230 bed. You can type here 230, 230. Okay. Print area size, you can give it here. Height you want to give here. So that is about your printer bed size. Okay.
Okay. Print area or only object area?
This is object. See, here we have two things. This is your maximum bed size and this is your printing area. You want to print between 200 to 200. You want to give some margin from the bed when you are going to print. So you can give print area width here, print area depth here, print area height here. Okay. Is it clear?
Yeah.
Okay. Now you have to practice it first. You have to place your part properly. Okay. And then we go for the settings of the part and then settings of the printer. Then tomorrow we go for tomorrow and day to tomorrow. Saturday, Sunday we don't have class. Now we have class on Tuesday.
Monday?
On Monday I am on leave because I have some work in our home. Okay.
That Monday leave class, we can arrange that.
Monday class we can forward to the next session. Otherwise,